Okay, so we have started solving systems of linear equations. We've learned every different type. So now we need to talk about the special circumstances that happen when we're solving systems of linear equations. And so first my question is for you, like, what can we do when it seems like we get a system that doesn't work? Not that we get a decimal or a fraction, which is when you guys like to tell me it doesn't work, but what can we actually do when it doesn't seem possible? Why would that happen that it wouldn't be possible? What must be true about the lines for them to not work, to not give us a solution where they intersect? So be thinking about that as we go through, and obviously we'll review this back at the end, what exactly it is that makes it them non-solvable. So, number of solutions. We've only talked about where we have the one solution. We get the 1 point. But actually systems of equations have three possible types of solutions. One could be that it has the 1 point like we've seen so far. The other ones could be that they could have no solution. We'll call that an inconsistent system. So typically, we'll see what it looks like when we have no solution, but that's when you get your variables go away and you get something that's false. Or we could have infinitely many solutions, which we also call a consistent dependent system. And that is where the lines are going to overlap. So when we solve it, we're going to get a true statement, like 2 equals 2. And that's going to tell us that we have infinitely many solutions. So let's take a look and see what those actually will look like. If we have this system here, 3x plus 2y equals 10. And 3x plus 2y equals 2. The first thing we're going to do is we're going to graph them. So in order to graph these, I need to solve for y. So if I'm solving this one for y, I'm going to have 2y equals 10 minus 3x. Y equals 5 minus 3 halves x. So my y-intercept is 5. And my slope is negative 3, so I'll go down 3 over 2, down 3 over 2, and I can draw my line in. And it'll look something like that. Then I go to solve this other one, and I would get 2y equals 2 minus 3x, and we get y equals 1 minus 3 halves x. So my y-intercept is 1. Go down 3 over 2, down 3, 1, 2, 3 over 2. Draw our line in. What do we know about these two lines? They both have a slope of negative 3 halves. These two lines are parallel. And what do we know about parallel lines? They never cross. So therefore, since they're parallel lines, this system is going to have no solution. Let's see what that's going to look like if we're doing elimination. So if I have 3x plus 2y equals 10 and 3x plus 2y equals 2. So for this one, in order to get rid of the x's, I'd have to subtract. But when I go to subtract this whole thing here, 3x minus 3x equals 0. 2y minus 2y equals 0. And 10 minus 2 equals 8. And so I would get 0 equals 8. We know that's not true. Therefore, again, we can see that there's no solution. There's no solution to this system. No place where these two lines are going to intersect. Let's look at another one. If we have x minus 2y equals negative 4, if we solve for y, we're going to get negative 2y equals negative 4 minus x. So y equals 2 plus 1 half x. So there's 2, up 1 over 2, up 1 over 2. Our line looks like this. We go to solve the other one. Oh, look, my y-intercept, let me change the color so we can really see. My y-intercept is 2. My slope is 1 half, up 1 over 2, up 1 over 2. these are the exact same line. Exact same lines intersect each other at every point, and that's why we would say that this has infinitely many solutions. If we look at that using substitution, this one's already solved for y for us, so we would just put it into the other one. We would get x minus 2 times the quantity 1/2 x plus 2 equals negative 4. When we distribute, we're going to get x minus 4 equals negative 4. X minus x is 0, so we get negative 4 equals negative 4. This is true, so that's how we can say there's infinitely many. If you were eliminating and you got a true statement as well, you would say that there's infinitely many. So there's another way to look at them without having to solve. And we can automatically determine the number of solutions they would have by looking at the slope and the y-intercept. So two lines with different slopes have one solution. We're going to find that one point where they intersect. If the two lines have same slopes but different y-intercepts, there's going to be no solution. These are going to be parallel lines. And finally, if it has the same slope and that says y-intercept. So same slope and same y-intercept. They're the same line, so that's why it's infinitely many. So that's a quick little cheat sheet to kind of figure out how many solutions there's going to be. Let's try a couple more. We're just going to determine the number of solutions. We're not going to solve, we just want to see how many solutions there are. So if I solve this for y so I can easily find my x and y intercepts, I'm going to say 3y equals 6 minus 5x, y equals 2 minus 5/3 x. And then if I solve this one, I'm going to get negative 3y equals 3 plus 5x. So y equals negative 1 minus 5/3 x. So these two have the same slope. Both of the slopes are negative 5/3. So we have same slope, but my y-intercept is different. So same slope, y-intercept's different. We would write no solution. These would end up being parallel lines if we graph them. Let's look at this one. Y equals 2x minus 4. That one's already solved for y. Let me solve this one for y. And we would get 3y equals negative 12 plus 6x. Divide by 3, I'm going to get y equals negative 4 plus 2x. They're written oppositely, but we know that negative 4 plus 2x is the same as 2x minus 4. We could rewrite this and it would be y equals 2x minus 4 or plus negative 4. And so therefore these are the exact same lines, so we would write infinitely many solutions. Alright, let's keep going. We're going to determine the number of solutions again. So if we look here, one second. Okay. We're going to determine the number of solutions. So if we look here, we would say y equals negative 2 minus 5x for the first equation. And for the second equation, negative 2y equals 4 plus 10x. Y equals negative 2 minus 5x. Look there, the same, therefore infinitely many solutions. Six x plus 2y equals 3. 6x plus 2y equals negative 5. Looking quick, if we did elimination with this one versus doing solving for y and comparing, if we did elimination, we're going to subtract this whole thing, right? So 6x minus 6x is 0. 2y minus 2y is 0. So we end up with 0 on this side equals 3 minus negative 5 is 8. We know that 3 does not equal negative. 0 does not equal 8. So we would write no solution. You can use any way, whichever way looks like it would be easiest for you to figure it out is the way I want you to figure out how many solutions there are. Let's try this one. If I solve for y, or I could eliminate or do whatever, let's eliminate. Ready? So I can subtract because my 3 y's are the same. So if I subtract, we get x minus 2y, which will give me negative x. The y's will cancel out, equals negative 15 minus negative 18 or plus 18 would give me 3. So I divide by my negative 1, x equals negative 3. Because I got a solution with x, I know that there is one solution. So I know I have one solution. I can then take that and go through and find the other solution. And I believe that I would find that y equals 4, I want to say. Yeah, that y equals 4. So my solution would be negative 3, 4. But since it just asked for the number of solutions, I could just say that there would be one solution. So now let's talk about a word problem that pertains to these. An artist wants to sell prints of her paintings. She orders a set of prints for each of 2 of her paintings. Each set contains regular prints and glossy prints as shown on the table. Find the cost of one glossy print. So I'm only caring about the cost of a glossy print. I don't care about the regular. But let's label our regular x and our glossy y. And I'm going to just write an equation for each painting. So I'd have 45x plus 30y equals my total of 465. And 15x plus 10y equals 155. Now to solve this one, I'm going to use elimination. So I need to multiply this bottom equation by 3, and the x's would cancel because I'm more concerned about my y's. I don't want to cancel my y's if I can avoid it, right? So if I multiply times 3, I would say that 45x plus 30y equals 155 times 3 equals 465 once I've multiplied this equation times 3. So looking at these are the exact same thing. So there are infinitely number of solutions, right? So the number of regular paintings and the number of glossy prints that she makes, there's not enough information in this problem to give me an actual. So there's not enough information in this problem to give me a solution. Because if I took this one down, this original equation I had, and I put it under, and I eliminated, I'm going to get 0 equals 0, right? If I subtract these two things, 45x minus 45x is 0, 30y minus 30y is 0, equals 465 minus 465 is 0. So that's telling me that there's infinitely many solutions. And when there's infinitely many solutions, we would say there's not enough information to determine the price. So I know sometimes you guys like to write not enough information. This is when you actually are not given enough information to find the price. So that would be how you would solve this one. So the last thing I just want to go over quick is a quick review of the number of solutions and kind of talking about, well, why are some of them not working, right? So the traditional ones we've dealt with are the one solution, where the lines intersect. We can find our one solution is their intersection point. The no solutions will happen when the lines are parallel. They're never going to intersect. Parallel lines have the same slope and different y-intercepts. And last but not least, we have infinitely many solutions. Infinitely many solutions, the lines will coincide or they'll be the same line. So these lines are going to have the same slope and the same y-intercept. They're the exact same line, therefore there's infinitely many solutions. So that's the review for today and the lesson for today. Tomorrow, remember, you'll have a quick DQ on this. So be ready for that and your assignment to work on that. All right, have a good night, guys. Bye.